Okay, this is the Unit 2 Test Study Guide, Part 1. Question 1, what is a rational number? Remember the key word here, ratio. And a ratio is a form of a fraction. And that's what a rational number is. A number that can be written as a fraction. Okay, then this part, whether a number is rational or irrational, is again coming back to, can these be written as a fraction? All right, perhaps the easiest one is number 4. You could write that as 85 over 1, so yes, that is rational. The other thing you need to remember is fractions. When we change them to decimals, 3/4, you would do 3 divided by 4, and you would say that goes 7 times, 28, subtract, you get a 2, then it would go 5 times. 3/4 as a decimal is 0.75. Remember, we had two options. Fractions, when they turn to decimals, would either terminate or terminate with repeating zeros at the end. We can tack on extra zeros. Or if you had a fraction like 1/3, if you do 1 divided by 3, you'd say it would go 3 times. That would be 9. Subtract, you get a 1. Bring down a 0. It goes 3 times again. You get a 9. Subtract, you get a 1. It's going to keep doing that. 1/3 as a decimal is 0.3. Repeating, it's going to keep going on like that. 3, 3, 3. Those were the two options. The fraction would either turn into a terminating decimal or a repeating decimal. And so, number 2 is a repeating decimal. That is rational. Number 3 is a terminating decimal. That is rational. Number 5, remember numbers like pi would be 3.14, but then they go on forever with the 3 dots. That's what this is showing. Remember, pi is irrational. Number 5, that is irrational. Next set of questions. To change a fraction to a decimal, remember the fraction bar is also a divisor bar. This is, well, the question is then whether you are going to do 7 with the 7 inside or whether you do it with the 8 inside. You're going to tack on a decimal point and fill in with zeros. If you were to do this one, if you divided by 7, you'd say it goes 1 time. We're getting a number that's greater than 1 by doing this. 7/8 is not greater than 1. This is not the correct way to do this. Decimal point would, this is the correct way. The decimal point would go straight up. You would say 8 does not go into 7, so we put a 0 above it. You could put a 0 here, but I know that's just going to bring my 7 down. So I'm going to instead say, let's do 8 into 70, and that is going to go, the closest we could get would be 8 times, and that would be 64. Subtract, you get a 6, bring down your 0, and then you'd say 8 would go into 60. The closest we could get would be 7 times 8, which would be 56. Subtract, you get a 4, which is a wonderful thing because now when you bring down your 0, it's going to go 5 times. That will be 40 exactly. You'd get 0. If you brought another 0 down, you'd have to say it goes 0 times. it terminates with repeating zeros at the end. We could put more zeros if we wanted, but we would normally just say, let's write it as simply as possible. 7/8 is 0.875. Don't forget though, this was a negative fraction. Our answer needs to be a negative decimal. Okay, number 7, 1/7 is a decimal. Would be, again, 1 would go inside, you divide by 7, tack on some zeros. I know this one is going to go 6 places before it starts repeating. You won't see anything this large or going this far on the test. But it will be the similar idea of saying, hey, we keep dividing until we see that it repeats. So 7 doesn't go into 1, so I'll put a 0 there. 7 goes into 10 once, and that would be 7 times. 1 times 7 is 7. Subtract, we get a 3. Bring down a 0. And then you would say it would go 4 times, would be 28. Subtract, I get a 2. Bring down another 0. Try to keep things lined up as you're doing this. You're filling in above this 0 now. 7 going into 20 would only go 2 times. That'd be 14. Subtract, you get a 6. Bring down another 0. And that is going to be 8 times that it would go. That would be a 56. Subtract, I get a 4. Bring down another 0. And the closest we can get is 5 times 7, which would be 35. Subtract, I get a 5. Bring down another 0. Closest we can get is 7 times 7, which would be 49. Subtract, I get a 1. That was the same thing I started with. If I bring down another 0, I would say that it goes 1 time. And then I would get a 3, and I'd bring down another 0, and it is going to go 4 times, 28. It's repeating. Write this as simply as possible. So 1/7 would be the same thing as 0.142857, and then it starts repeating. Don't put another 1. Stop there. Put a bar over it to show it repeats those digits, and that is your answer. It was a positive fraction, so yes, we should have a positive decimal. Right. Next part. Changing decimals to fractions. You've got 2 ways to go here. One way is to do what Mr. Jordan kept showing, which would be put the number over 1, because you can always put a 1 under a number. Then to move the decimal point, remember you can multiply by 10 or 100 or 1,000, and that moves the decimal point. You multiply times 100, do the same to the bottom, and you get 36 over 100. And then reduce it. He would do prime factorization. I tend to say, let's just divide each time. We can divide by 2, and we would get 18 over 50. Divide by 2 again. You're going to get 9 over 25, and that is reduced. 9 is only divisible by 3, 25 divisible by 5, and 1 and 25. They don't have any common factors. You're done. But don't forget, this was a negative decimal that we started with. We need a negative fraction, so the answer is negative 9/25. The other way to do it is read the decimal properly. You say it's 36 tenths, hundredths. Read the last column you're out to. It's 36 hundredths. That sounds like a fraction right there. And then do the reducing we just did. You'll come up with that same answer, negative 9/25. I prefer this second method, so that's what I'm going to do here. Read the decimal properly. You'd say that it is 84 tenths, hundredths, thousandths. You're out to the thousandths columns. It is 84 over 1,000. And then reduce from there. Again, I would say, let's just divide. Divide by 2. 84 divided by 2 would be 42. Divide the bottom by 2. You'd say that becomes 500. Then divide by 2 again. You get 21 over 250. 21 could be divided by 3 and 7. 250 is divisible by 2 or 5 or 10. It's not divisible by 3 or 7. So you know you've reduced it completely. So your answer would be 21 over 250. Next problem, same thing. Read the decimal properly. You would say that it is 8 tenths. Reduce, they're both divisible by 2. And you'd say that that becomes 4/5. Again, don't forget, negative decimal. We need a negative fraction. So the answer is negative 4/5. All right, simplifying fractions. Basically, that's what you were doing there. Reduce. Both of these could be divided by 2. Divide by 2. You're going to get 36 over 42. Okay, they're both divisible by 2 again. So it's going to be 18 over 21. Okay, this time they're not divisible by 2, but 18 is divisible by 3. 21 is divisible by 3. We can divide them by 3. And then you're going to get 6 over 7, and that is your answer. 6/7 when it is reduced. Number 12, 96 over 150. Divide by 2. You can divide by bigger numbers if you recognize it, but I'm going to just keep going with something simple. 2 would go into 9 4 whole times. You'd have 1 left over. That would make this 16. 2 would go into 16 8 times, so that becomes a 48. 150, well, 2 doesn't go into 1. 2 would go into 15 about 7 times. Again, I'd have 1 left over, 110. So a 10 divided by a 2 gives me a 5. It helps if you think of that as money. $1.50 divided in half, 75 cents. Okay, well, they're not divisible by 2. 75 is divisible by 5, but 48 is not divisible by 5. You should try 3. 48 is divisible by 3. Both of these are divisible by 3. So divide by 3, you're going to end up with 16 over 25. And again, don't forget, look back at the problem. You started with a negative fraction. Your answer had better be negative. So negative 16/25. Okay, it looks like I'm going to have to pause there because this recorder has a 15-minute time limit.